Hello there. This is Mrs. Peterson back. We are going to be working on the review lesson today because this is a skill that we need for the next thing that we're going to work on. So for today and tomorrow, actually, we're going to review factoring. So factoring is that GCF, TLC is equal to 1, TLC is greater than 1, PST, and DS. So I'm going to go through a couple of examples of each. Again, I have skeleton notes you can print out, but this is probably not as important for skeleton notes. There's no graphs or anything like that, so you can just write them down in your notes. A reminder that writing things down will help you remember. So I know that I do include a filled in version of the notes, but it's not the same reading it as going through the notes with me step by step. So please do this so you are successful. All right. So the first type that we're going to go through is the GCF factoring. In order to do that, of course, we have to find the GCF. Remember, the GCF stands for greatest common factor. And then we basically have to divide it out. Okay. So how this looks is this. So the first one here, we've got 3x squared plus 9x. And remember, at any time, if I'm going a little too fast, feel free to pause, get like this written down, and then come back to it. So here, the GCF between 3 and 9 is 3. And then we have to look at the variables, and they have an x and an x. So what do they have in common? They just have one x. Remember, if they both have the same variable, you are going to take the one that has the smaller exponent as the GCF. So that is what goes on the outside of the parentheses. And then you need to divide the 3x out of both of them. And I would get x plus 3. And that is my factored form. And that's what we're going to be using for the next section. 3x and then x plus 3. Remember, you could check it by distributing it, and it should equal what we had up there. All right, so the second one here, GCF, 4 and 2 would be 2. And this has 5 x's. This one has 2 x's. So the GCF would be x squared. So take the smaller of the two. That goes on the outside of the parentheses. Divide them both by 2x squared. I get a 2x to the third. And then I got plus 1. And that's the answer. Okay. It'll be really nice for you to have, examples of all 5 of these also on your in your homework or in your notes, just so that you remember how to do each of them. All right, so the next one is TLC is equal to 1. Remember, TLC stands for trinomial leading coefficient. So this one has to be a trinomial, and it has to have nothing in front of the x squared. So our thing that we said then would be find factors of C that add up to B. So this is what they look like. As a quick reminder again. All right, so you can see they're trinomial and there's no number in front of x squared. That's how we know we can use this method. And so A in this case would be 1, B is 6, and C is 8. So find factors of C that add up to B. So I'm going to write the C off to the side. That's 8 in this case. And what can you multiply to get 8? I can do 1 times 8 or 2 times 4. Which ones add up to 6? The 2 and the 4. So this is where you just set up your 2 parentheses with the x's. And if it says 2 and 4, it's a positive 2 and a positive 4. And that's it. There's your answer. Okay, so number 4, our C is a negative 50. So if C is negative and we're finding factors, we have to use one positive and one negative. 2, 25, 3, 5, and 10. And I think that might be all, but I can see if I have to add up a negative 5, that if I have a 5 and a negative 10, they multiply to negative 50, they add to negative 5. So you set up your sets of parentheses, x, positive 5, negative 10. It does not matter what order those things go in. So if you had the negative 10 here and the positive 5 there, that's totally just fine. All right, TLC is greater than 1. This is the one that the steps are kind of so big that I could not put them on our sheet. but we call it the AC split, and then we added squiggle method. And you should still have these in your notes. Hopefully you guys got your notebooks home. And I'll do these two examples so that you can kind of remind yourself how it works. AC means we have to multiply A times B. So 2 times 21 is 42. And we have to find factors of 42 that add up to 13. Factors of AC to add up to B. I feel like there's more factors, but I could kind of see that 6 and 7 would be the ones that multiply to 42 and add 13. That's the AC part. Now we're going to split B. So using those two factors. So I would have 2x squared. Now instead of 13x, I'm going to do plus 6x plus 7x plus 21. Okay, so that's the split. Now we can squiggle. So remember, you're going to do a mini problem with the first two and a mini problem with the last two. So it's a mini GCF. So what goes into both of these two, and they both have an x, right? So I have 2x actually divided out. So I'd have x plus 3. That means I'm going like this. Now the GCF between 7x and 21 would be a 7. You see that they both don't have an x. So you can't include that. And I get x plus 3. You are correct if these two are the same at this point. They are. So I'm going to do x plus 3 inside parentheses. And my second set is what is outside. So 2x plus 7. That is the factored form, the solution. All right, so let's try one more that has a negative sign in there. And if you want to pause, try it on your own, and then come back and see if you got it right. That would be a good idea. But my A times C is a negative 18. So I'm going to use one positive and one negative, and they have to add to a positive 7. So I'm going to use negative 2 and a positive 9. So now I'm going to split up B. So I'm going to have 6x squared plus negative 2x plus 9x minus 3. I could have just done a minus 2x there too. Now, squiggle, what's the GCF between these two? Looks like I'd have 2x. So I'd have 3x minus 1. So I'm going to divide both those by 2x. GCF between 9x and 3 is a 3. They both don't have x on this side, so we'd have 3x minus 1. Then we've got what's inside parentheses. And what's outside is 2x plus 3. 2x plus 3. And there's our solution. Okay. All right, so we got 2 more. Try not to make it weird there. Okay, so the next one is perfect square trinomials. We need to use perfect squares to solve it. And our answer is going to look something like this. It's going to have one parenthesis and a squared on the outside. We know you can use this one if it's a trinomial and the first and last are perfect squares. So if you need to remind yourself, that's like 1, 4, 9, 16, 25, 36, 49. I can keep going. You know, that's to 100. You might need more than that. But they're numbers that you can take the square root of, and it comes out to be perfect or an answer that's not a decimal. So now 4 and x squared are perfect squares, and 9 is a perfect square. So just the first and the last have to be perfect squares. You don't have to worry about the middle. So all we do is take the square root of the first one. So that would be 2x. We take the square root of the last one. That would be 3. And you bring down the first sign. That's it. That's your answer. Many of you say, well, what happened to the 12x? How did that work? If I really quickly multiply this out, so I've got like 2x plus 3, and I'm going to try and write it small so I can fit here. You know, 2x plus 3 squared is 2x plus 3 times 2x plus 3. I've got 4x squared. Remember, we have to do that whole FOIL or 4 things to multiply out. Plus 6x plus 6x plus 9 we have taken care of the 12x. It's there. If you multiply it out, it's going to equal that. It's just kind of magic how that happens. All right. So then this one, same thing. We've got a squared. Square root of the first one would be 6x. Square root of the last one would be 5. Bring down the first sign. It's a plus. 6x plus 5 squared. Okay. And the last one is difference of squares. Yes. This one's the easiest to identify because there's always only two terms. They both have to be perfect squares. So remember our little list up here, and it could go farther. And there has to be a subtraction between. We're going to use the perfect squares, and our answer this time is going to have two binomials, one with a plus and one with a minus. So now, if we're doing this one, we take the square root of the first one, which is 3x, and put it first in both of the binomials. Take the square root of the second one, which is 5, and do a plus and do a minus. That's it. I like this one. So example 10. Again, maybe you can pause it, see if you can get it, and then check it. So I'd have 10x, square root of 49 is 7, and use a plus and a minus. All right. And that is basically how a review of factoring. I would keep this by you as you're working on your assignment so that you remember or have some examples you can go off of so that you can see it. All right. I will see you later.